The purpose of our project is to get like little kids excited about technology and stuff like that, and show them that the naked circuit board isn't anything to be scared about. That not just nerds can do stuff on like naked circuit boards. There's a bunch of people that a bunch of projects that you can do. The first project we did was Rachel made an instrument out of Explorer.
Well, yeah, it's the Arduino Explorer, which is a lot different than any other Arduino model that I've worked with before, because instead of having to actually build everything yourself and add all the different parts, it's pretty much like everything you could use is already built in. So coding it was a lot easier. It started out as like a theremin where you just move your hand away from the light sensor to change the pitch, but it was really buggy and didn't really sound that good. So I changed it so that the light sensor, when there's not enough light hitting it, it plays a tone, and then the slider will change the pitch. And to make it, I guess, a little more interesting, I used the accelerometer to change the color of the LED, depending on its position. And that's about it with this. It's pretty simple.
And next thing we did, I'm Tabor by the way, we made a 3D touchless interface, and basically this device it takes tinfoil, and this tinfoil acts as capacitors, and these capacitors, the voltage changes as your hand gets closer because the conductivity of your hand changes the voltage. And then the program that we got, yeah, we should call it the program. The program that we got, we're on the first. Okay. The program that we got, it takes into account how long it takes to charge fully each capacitor, and from that, it takes those 3 capacitors and spits out a number, and that number basically quantifies where your hand is in the box. So we'll show you right now is it not in this?
So the first step with the Arduino is you have to write the code, which is much like some of the Flash programming that a lot of you have been doing. But the cool thing about Arduinos is that next, once you hit go and the serial monitor or the serial port is correct, then the code is changed directly from syntax to assembly code to binary on the Flash or the microcontroller on the actual device. So for those of you doing just software programming, if you want to actually make hardware and do stuff, you have to do one more step, which is to change the assembly code, not just to binary, but binary that arranges little devices on a microchip. And so that's the cool part about Arduino, which allows you to control hardware like sensors, motors, speakers. So the tricky part though is getting the hardware to sync together, to act in the right order, which is why it usually takes a while.
Good. This is we have the right board on it. No, the board. Was it good? Alright. See that? Oh goodness. Okay, so while we have technical difficulties, we also programmed an interface for this to show where your hand is actually located. And so we can't get the processing.
There's a reset button on the Arduino.
Yeah, but it's not even picking, the serial port isn't picking it up at all. But, so, go to 6. Okay. No, that's the circuit, sorry, 7. So we programmed this GUI to basically show this. There, I don't know if you can see very well, but there's a little sphere right here, and basically that sphere represents your hand. And the sphere moves around with your hand. And since we're going to be showing this to mainly kids, we then tried to take that interface and add a monkey and make it a game for the kids. So there's a monkey that we rendered in Blender here, and then we were putting bananas in the box to try to get the monkey to eat the bananas by moving your hand around to try to catch the bananas. But for some reason, the bananas were only loading, black bananas, and they weren't. They weren't staying. We used a code called processing that was developed at MIT, and the way you get things to show up on processing is through a method called void draw. But void draw draws things every frame, so the banana was jumping around every single frame, so there's no way the kids could catch the banana. So they'd be kind of mad at that. So we decided to scrap the banana for right now, since we have a presentation. But in the future, that's what we'd like to try to do: get a whole game environment for the kids out of this circuit board and cardboard with tinfoil on it to show that you can make this really cool interface. And then the next slide, some of the future we're looking at. The student outreach will make improvements on this because sometimes, obviously right now it's kind of buggy. And we also had multiple projects that we didn't get to because there were a couple projects that proved to be difficult because we were doing them incorrectly. We also had a muscle sensor project that the chip burned out the first day, but we didn't realize that, so we kind of spent a week and a half trying to build something with burnt out microprocessor, and that wasn't fun. And we also were going to develop a head mouse, which basically you wear this funky looking hat and you can control your computer with a funky looking hat. So that's the TAPS project's future, is to show students basically how technology can be really fun and how science and technology, when they come together, can be something really cool that they can do at home for pretty cheap prices. Here, let's try to get this thing running. Are there any questions while we're doing this?
What was the most difficult part of it, other than getting code to compile right now?
Well, I think the most difficult part was actually implementing. I think we spent 2 or 3 days trying to implement the Blender sketch of the monkey, because it would just bug out the whole program, and the computer would crash because the program would crash and then you couldn't get it to reload. And then obviously processing looks like it looks like it's written in Java, but it's not. It's this whole different language. So we thought it was just written in Java, and so we tried to write Java in a program that wasn't Java. So that was kind of difficult to do.
Is there a transmit that's supposed to be working?
Here, Tabor. How big is the program? Just kind of how much information it takes up in the computer?
It doesn't take that much because I was running YouTube while I was doing half of this.
Basically, it's just a few, like a kilobyte.
Mm-hmm.
Yeah, it's real simple.
So you have the code on the Arduino, and then you also have the code on the computer running and processing, and they're interfacing with each other.
Yeah, they're yeah.
Well, I don't see the transmit. I never see why it's working.
I think your board got changed too.
The board got changed?
Oh, yeah.
Do you need the? What if I change the USB, the other?
Did you receive that recently?
Yeah, I did receive it. It's working like, you know,
Yeah.
at 10:30.
It was this morning.
Oh wait, here,
Wait, this is.
you have processing you're running right now, so you
Oh.
can't get the serial port, so stop processing.
Okay.
So no, try stop both of them, there's two of them open.
I thought these ones were just-
No, they're like both of them are open, yeah, they're stopped.
Yeah, this is y'all's first taste of hardware programming, isn't it? No,
That's why I get the extra.
I should get rid of the
Yeah.
one.
this is kind of an oversimplified version of, for example, programming a cell phone, which is something that we do in Dave's group occasionally. So, yeah, if you want to control hardware, basically the idea is learn how to program an FPGA.
Out of curiosity, how many people here have used Arduino before? So can you guys tell them like price and like learning curve? Like how easy is it to learn how to use an Arduino?
I say it was pretty easy, like, I came in and pretty much picked it up in a couple of days, if that. It's mostly like a bunch of, it looks like C code, and then the price range, it varies, like,
Oh, 60.
60, and then some of the smaller ones, like Uno and stuff, are like 20. Yeah, they're pretty inexpensive, yeah.
It's weird that it takes that long to load the source code. But it's like if it can load the code, then how is it not?
I don't know how it's not communicating. No. It didn't go inside. That's the correct.
By the way, do you need auto scroll?
Well, yeah, usually for auto scroll serial ports, it changes it shows you what it changed. Here, why don't we just close processing right now?
I think those are on the other.
Yeah, just yes, that's the monkey one, so.
Is there another port?
It doesn't look like, it looks like there's one port out there.
So did you guys have something else running on that Arduino before today?
No.
If you didn't, then the code's already on there.
Well, yeah, but it doesn't show up in serial.
Oh, okay.
That's why.
But maybe what I'm saying is maybe you can open that serial port with your processing script, because the Arduino's already doing its thing.
Alright, yeah, let's
I
try.
wonder if one of the serial ports is taken up by the projector, since you have to have it.
Yeah, it doesn't look like it's running too good. Alright, well, maybe we'll get this running later, but. I know. Can we take it off the projector?
Oh, okay.
Oh, there we go. Alright, let's see if this works, right?
Is it calibrated?
No, that's what we're gonna do right now. We're gonna try to
Oh,
calibrate
okay.
it. Alright, 1, 2, 3.
So what they're doing now is
There we go.
Rachel's holding down the mouse, and that tells the program to record the baselines for the capacitors. Just how long does it take each RC circuit to charge, given his particular capacitance between his hand and the tin foil. And that's all it takes. It's a matter of calibrating it, and we have a 5-volt line to charge the circuit. The 5-volt is built into the Arduino itself. One tricky part about this program is that what is ground? So like you can't charge anything, in just free space. You have to have 5 volts and ground. But the ground comes from the computer, which is then fed to the Arduino, which is then fed to the RC circuit. So if the colors is new. I didn't know about the colors. If you don't have a proper ground in these hardware circuits, then relative voltage differences become meaningless. So it just ends up being random noise. So yeah, if you guys want to play with this circuit, you're more than welcome.
We'll leave this up after the last presentation. People can come up and see if they like it.
By the way, this is a highly simplified version of like the touch screens that you normally use. It's just capacitance, right? But, much finer detail.
So what determines if the box goes red or blue?
It's
The tab key.
Yeah. So, all right, that's it. Thank you.